Hi, we're Elizabeth and Sophie, and we're group 11, and this is our locker design.
Alright, so here's the closed locker, and from this point, I don't know if you can see, but here's our switch, and it's open. The switch is open, so the light is not on. But when we open the locker, the switch gets pressure right here when the door is open, and as you can see, the light goes on. So, what just happened? Is the light on? Okay. So, our light doesn't.
It's on.
This causes friction and like pressure on the switch right here, and then you can see the battery is up here, light bulb down there, and then there is a resistor right here. So that kind of slows it down and creates a longer battery life.
So our model doesn't exactly show what a locker hinge looks like. So if you can see that a locker hinge would be like this. So when the locker is closed, the hinge is more open in the inside because it creates that opening for it to be closed. And then when the locker is open, it pushes like this. So this is like our more accurate example of like how it would work, and because the switch would be pressed when the locker is open like this, and then in the open space it'll be open like this. So that's how we did this. And then our scientific concepts for our lab is this switch is when it's open, like we said, or open, the light won't turn on, and when it's closed, when we open up the locker, the light will turn on. Oops.
Oh, it's upside down.
It's upside.
Yeah, that's mine. There wasn't one for a yellow.
Never mind. Well, you only.
Okay.
Okay.
So,
When
anyways,
it's
open, the light will. Oops. Couldn't get it. Okay.
got it.
Yeah. Okay, when it's open, the light will be on, and then we have the resistor, and the resistor slows the current because it adds more friction to it, and it just creates the current to be slower, which helps preserve the light in our locker, which makes it more cost effective. And the switch being open all the time makes it more cost effective because the light is off usually a majority of the time. So.
Okay, and speaking of the longer battery life, we found out that our battery has about 11 hours, and then we divided it by the 0.24 amps, which leaves us with 45 hours of running light. So we know that'll last a really long time, and that's pretty effective for our lockers. And then cost-wise, it's about $5 per battery, $1 per light, and then $3 for the locker. So the total is $9 per locker. And I think that's about it. We're excited about our design.
Yeah.